For our assignment, we had to build a robot that would follow a line and then count marks on that line, after which the robot would come to a stop. I built a very unique line tracking robot. I chose a three-wheel design as it would be simple to build and simple to code. With a single wheel on the front axle driven by one motor, the inchworm robot was capable of constant speed line tracking. A second steering motor rotated the entire front fork assembly and drive axle. Rather than having a skid steer design, this rotating drive axle made my code short and simple. The drive motor almost never stopped, and the steering motor was able to keep the line trackers on the line at all times. I settled on a three-wheel design. This would allow for one wheel to be the steering wheel and drive wheel all at the same time, letting the other two wheels simply follow along and hold the weight of the robot and maintain stability. I attached an array of 3 sensors at the front of my robot ahead of the drive wheel, so as the drive wheel turned, the tracker would turn with it. The sensor array would turn with the front drive wheel. Originally, my robot had a servo motor as the steering motor. I quickly found out that this was difficult to code for. What would happen is I'd tell it to rotate to 50 degrees or 60 degrees or 37 degrees, and I needed a motor that would rotate more or less than that. I couldn't just go to one increment. I needed to continuously rotate until the line trackers were back on the line. So I opted to not use the servo motor, and instead I changed for a DC motor. This was easier to wire and not hard to add to the modified design. In my steering mechanism, I started with a large gear driving a small gear. That way I could have a finer rate of control, that the motor speed wouldn't be too quick or too fast, that I could fine tune it because I've got lots of room to play with in the way that's coded. However, I also did the same thing with the front wheel. I had a small gear from the motor driving a larger wheel. Again, I tried to have finer control, but this didn't work. What I had to do is I had to have the motor driving a large wheel and the wheel being driven on the smaller gear, because with the large gear on the wheel, because they're both parallel on the same axle, as a robot would turn to the left, the gear would actually touch the ground and lift the wheel, and the robot would stop driving, which was kind of funny to watch, but it was tricky. It wasn't too tricky to solve and not a huge problem. So in the initial testing with that, the robot would turn to the left or the right and oversteer, and it'd fall over. It would fall over and crash to the ground, and that was not good. I came up with building 2 outriggers. I chose not to do wheels because I didn't want to impact my steering system already. So I used 2 outriggers, 2 little arms, and if the robot oversteers, they'd contact the ground and prevent it from falling over under its own power. So making sure the robot didn't fall over was a challenge. Making sure I had the right steering mechanism was a challenge I faced. And they weren't too terribly difficult challenges to overcome. All I had to do was make a couple slight changes, change the servo motor to a DC motor, and add 2 arms to the side. What was the most challenging part is the sensor array. The sensor array on the front of my robot has 3 line trackers. And getting those to coordinate between each other and getting them the right distance off the ground and the right distance apart from one another in order to track the line effectively to go around the tight curves and the straightaways was probably the most difficult part I had. Writing the code wasn't too difficult. It was just a bunch of if statements nested into each other to go, oh, if the center sensor sees the line, drive straight. If the center sensor and the right sensor don't see what they're supposed to see, so the center sensor wouldn't see the line and the right sensor would see the line, turn to the left, and it would do that, and vice versa for turning to the right. That wasn't too difficult, but getting these things to turn in tight corners was difficult, as the line trackers would kind of all come off the line all at once. So getting the rotation speed of the wheels down and the steering speed to match that was a challenge, and I had quite the time doing that in the second part of the assignment, where I had to count the hash marks. So in the second part of this assignment, I had to count hash marks on our track and go over them and count them and then stop after I reached the 4th one. So our track had 3 hash marks, and I'd start behind the first one, it'd go over, count it, and then it'd come back and you'd count 2 more, so that would total 3, and then on the 4th line, which is the start line, it would stop. And what I found out is that the sensors would, initially they would see the hash mark and they keep counting, so I go from 1 to 5 on the first hash mark. So I ended up putting a delay into my code so it would see it and then wait and then write to the counter in my code before telling it that it had seen a line. So it would cross the line, it would wait, and then it would say, oh, I've seen the line, and then that would go to my counter. Making that all display on the LCD screen on the Arduino Mega was not too terribly difficult. Just getting the characters all positioned right was a little bit of a challenge, but it was just a matter of figuring out what would fit where and how that would fit. That wasn't hard. Having the display on and showing my line values, that was very helpful to me, so I could help diagnose what's turning too quickly or what's not turning too quickly, and seeing what the sensor sees before I'd make a change to my motor speeds, be it the steering motor or the directional motor. Overall, I had a fun time with this project. It was way more fun than the Squarebot. I liked seeing this thing go around. I even set up a track at my own house to help me with coding this and working out the kinks and bugs. And this was a great project. I really enjoyed it.